Hello everyone, my name is Xinghao Wang, the leader of Group 6. My teammates are Xu Liu, Sen Zhang, and Wu Zhang. In this presentation, we will introduce our final project, Database Query Assistant, which is the stage 2 of our web-based database query system. There will be 5 parts. In the first 2 parts, we will discuss the basic structure and the logic of our project, and then explain the code in detail. Then we will show you how to create Alexa skill and the way we use it in our project. Finally, we will talk about SQL query intent and advanced query intent and show you the result. Okay, let's start. This project is to create a voice assistant, allowing user to use voice to interact with our web application. And this project is based on our first project, web-based database query system. The platforms we use are EC2, RDS, S3 Bucket, Alexa, and Lambda. We use Python and Boto3 for data loading and processing, Django and Bootstrap for web development, MariaDB, PyODBC for database connection, Django Tables2 for query result rendering, Request for sending the signal of HTTP GET, and Alexa Skill Kit for converting the voice input to SQL query. The structure of our first application has 3 layers: client end, web server end, and database server end. First, user send a SQL query request to web server, and then web server get connection with the database server and fetch the data, and then return it to the user. Let's see the code. This is the main body of our web server. Every request corresponds to a function. For example, when we visit the home page, we will run the index function here. As you can see that we link the home page with the index function. Okay, in the index function, it is pretty easy. We just return the rendered page. In order to show you how it works, let me give you a simple demo. First, we open the web server page and we choose the insert card, and we input a SQL query and submit it. As you can see here, in our URL, we have select and we have text. Select is for storing the choice of RDS and Redshift. And the text is for storing the SQL query. And when we get the GET request, we will first check if it is RDS or Redshift request. For example, if our request is now RDS, the first step we want to do is we want to initialize the MariaDB connector, which is defined in here. The connect function will connect the RDS database in the AWS, as you can see here. And we pass the username and password, and now we connect it and get the cursor. And we want to do some error check here in order to improve the robustness. And set query is just get the query of the user, and perform the query is to get the result and do some later massage to the result to feed it to render table function. The Redshift connector is like the same, so let's continue. After we initialize the MariaDB connector, we want to start the timer and get connected to the database system. And in order to get the query command, we need to find it in a text domain of the HTTP GET request. And after that, we set the query and perform the query and get the result. And one thing to mention here is we also want to store the result in a global variable called Alexa result. And because we will send the HTTP GET request in the Alexa part too. And we want to send the request in this search text page because we want to avoid redundant code. And after that, we will do some error control. If everything is fine, we just render the table using the results and get the rendered table. And we activate the sorting and pagination function. And then we stop the timer and send the message, which include the query status and the query time. And finally, we render the page with our rendered table. If something wrong happens, we just do some we just send the message and redirect to our Instacart page. And the Redshift part is like the same, so we will skip this part. And also ABC Retail is just another database. So the structure is basically the same with the search text here. So we will just skip this part too. And as we can see here, this function is to deal with the Alexa function, Alexa results in the next section, which is the assistant part. And because we have already get the result and the time, so it is pretty simple. We just render the table and send the message, and finally render the page with the rendered table. Okay, let's continue. The voice query logic is that first, users say a query command to Alexa device like Echo Dot or smartphone. Then Alexa voice service will classify the command to a specific intent in Alexa skill. And query intent handler in AWS Lambda will be activated, and it will convert the voice command to a SQL query, and then send a HTTP GET request to our web server. When our server receives the request, it will get the data in the database server and update the data in the Alexa page. User will see the updated table in the page because the page will automatically refresh itself every 3 seconds. Next, let me introduce our Alexa skill. Our skill has 3 main intents. The voice recognition model will forward the converted voice text to one of them according to different utterances in different intent. The SQL intent will handle the SQL query, and the other 2 intents will handle some advanced query commands, like find the most popular product. Now, let's see the real picture. Before we dive into our skill, I want to show you how to create a skill. First, we can click the Create Skill button. And here, we can give the skill a name, like test skill. And we can choose the custom choice here, and we want to select the Alexa hosted in Python language. And we click the create skill button. And we can choose a template like Hello World and some game. Here we just choose the Hello World template, and we need to wait for some time to create a model. Okay, now you see that the skill is successfully created, and we can change the invocation name here. So every time you say Alexa open test skill, it will open this specific skill. And then intents, there are 5 built-in intents here, and the slot type is 0. Okay, now let's see the skills we have. As you can see here, other than the test skill, we got database query assistant. This is the live version, which means that you can find this skill in the Amazon Alexa skill store, and you can just search database query assistant, and you can install it, and you are ready to go. And here we get another version, which is database query assistant 2. This is still in development, but all the functions are complete. So I will use this skill to do the demo. Okay. Now we can see that the invocation name is database assistant. So that means we can just call Alexa open database assistant. Okay. And we can see here there are 8 intents, but five of them are built-in intents. So our main contribution is the SQL intent and IO department advanced intent, product advanced intent. Okay. We can check the SQL intent first. You can see that the intent is composed with the utterance and slots. Every utterance is an entrance to this specific intent, and we can add some slots here, and slot has its slot type. So we need to add slot type in here. We can add a slot type and give it a name. And click next, and we can input some test value, as you can see here, or we can bulk edit, and we can drag a CSV file and click submit. As you can see here, we have 12 slot types in total. And some of them are names like aisle name, department name, and product name. All the product name in here, the length of them are smaller than 6. And some slot types are keywords like where, and some of them are operators. And one thing to mention here is there is synonyms domain here. So you can see this slot as a dictionary. So when we say unequal to or not equal to, we can take it as the key, and the corresponding value is this operation. So when we say a word, it will first find the most similar key, for example, unequal to, and then it will return the value here. Okay, in the following sections, my teammates will introduce the detailed version of every intent, and they will explain the specific utterance and the slots to give you a better understanding of our Alexa skill.
Hi everyone, I will introduce the SQL intent part in our final project. The SQL intent could translate your vocal commands into SQL queries that is legal to run on our backend, running on EC2 instance. So we first build some utterances for the SQL intent. As you can see here, we built many SQL intent utterances, and there are many placeholders that you can let the system to replace your attributes or tables to the corresponding places. And for here, we mapping our placeholders into the slot types. So let's see our slot types. As you can see here, we have we have pre-imported many slot types like attributes. You can see that we have introduced all the column names for the Instacart into the slot types, and all the synonyms are corresponding to each slot that could like the Alexa map what you are saying into this attribute, and something similar happens here. After you imported all your slot types and the intent, you can click save model and build the model. After a while, you click code. You can find that Alexa will automatically generate some code for you, and we modify that code based on the automatically generated code. So the SQL intent part is mainly about here. First, we add some aggregation keywords. Then we will dive into SQL intent handler. In this part, the code will translate your vocal commands into legal SQL queries. So here we can see the slot. It is generated by Alexa with a nested JSON object. It could be used as a dictionary, as you can see here. So this will represent the tables in the slot types. If you say something in this part, in the synonyms part, the Alexa will map your voice into a best match to any of these tables. So if you print the slots, you can see that it is a nested JSON object. So this is what slots looks like, and as I said before, it is nested. So this will give you the best match from Alexa to the table slot, something like any table in the slot types that you pre-built before. So in here, we start with building our SQL query. We start with select, and then we will find attributes. If you say anything in attributes, that like here, if you say 3 attributes, it will parse every attribute from it and add to the SQL query. Then you should select something from the table, and if you say more than one table, it will join together, and something like that for group by and heavy, and with all the parsing done, you can see the SQL query in the log, and in the end, we will send our SQL query into our backend through HTTP request. Then let me show you how it works. You click test here, you can get into this page, and you click and say open database assistant.
Welcome. What query would you like to try? Or you can say help.
So as you can see here, the system is switched on. Let me try for one query with select all from products where IOID smaller than 3.
Understood. Getting the data.
So as you can see here, the results has products with IOID only in 1 and 2. Let's try another one. This is with where and select from. Select product ID, product name from products ordered by 1, descend.
Okay. I have fetched the data.
So 1 here means the first attribute, which is product ID. As you can see here, this is successfully ordered by product ID. So let's try another one with group by. Select product ID, count of all from order products group by product ID having count of all smaller than 3.
No problem. I'll do the job.
So this is the sample with having and the group by. So here let's look at the SQL queries. So for the first command, you can see the SQL queries has been translated successfully. And for the second one, we can see it is here. Select two attributes from products and order by the first one. And the last one is group by product ID and having count smaller than 3, which you can see here. There's only count of 1 and 2, and that's it.
I'd like to show you some more SQL commands in the left page, and I will read the commands one by one, and let's see the result. Select department from departments.
Okay, I have fetched the data.
Select all from products, limit 100.
No problem. I'll do the job.
As you can see here, every page has four. There are 4 pages, and every page has 25 records, so that's 100. Select count of all from aisles.
Understood. Getting the data.
Select count of all from older products, natural drawn products.
No problem. I'll do the job.
Select all from products, natural drawn aisles, natural drawn departments.
Okay, I have fetched the data.
As you can see here, we join the product and aisle and department table successfully. And let's continue. Select product ID, product name from products where product ID is smaller than 3.
Understood. Getting the data.
As you can see here, the product ID are all smaller than 3. Select order ID, product ID reordered from older products where reordered equals 1.
Okay, I have fetched the data.
As you can see here, we just choose the order. We just choose the order and which has been reordered. Select top 25 product ID, product name from products ordered by 1 descend.
No problem. I'll do the job.
Select order ID, order number, order day of week from orders ordered by 3 ascend.
Understood. Getting the data.
As you can see here, the order day of week is ascend is by ascend. Okay. Select order ID, max of add to cart order from order products group by order ID.
Understood. Getting the data.
Okay. Select product ID, count of all from order products group by product ID.
Understood. Getting the data.
That's also good. Select product ID, count of all from order products group by product ID having count of all bigger than 10.
No problem. I'll do the job.
In this part, I will introduce another intent. that is, less. Different from the circle intent, the utterances of the intent is ordinary, which are friendly to the people who know little about circle language. Let's look at the details of the intent. First, let's look at the utterances. The first three utterances can deal with the situation in which it can show the aisles or the department with the most of your list products. The following three utterances can deal with the situation where it can show top three aisles or department with the most of your list products. The three, please note, 3 is just a number. It can be any number. For example, it can be 4, 5, 6. And the last four utterances can deal with the situation in which it can show all the products of the specified aisle. And in the utterances, we can see there are 4 nodes that are aisles, numbers, target, and sequence. It has corresponding node type. So let's look at node type in detail. The first one is aisle name. Its value can be all attribute values in the aisle table. The second one is empty number. It is a building node type. And the third one is the sequence. The value can be assigned or deassigned. And for the ordinary people, it has some synonymous. You can see the fewest, smallest, least, biggest, largest, or most. And the last one is the table. And in this intent, the table can only be two values, that is, aisle and department. Then, let's look at the code of the intent. First, we need to extract a node from the utterances. And if there are at least 2 nodes in the utterances, it means we need information about the aisle or department with the most of your list products. Next, we extract the corresponding node value and construct the circle language. This is the part of constructing the circle language. In order to get the information we want to get, we first join the table, product, and the specified table. Let's take the aisle for example. So we first need to join the product table and the aisle table. Then we extract the aisle ID, aisle, and use the aggregation function count from the joined table. Next, we group by the aisle ID. Next, in the result sets, we group by the aisle ID and order by the count. or by the count. In addition, if we want to the information about top 3 aisles with the most products, we also need to provide another slot value, that is number, and use the limit to realize the whole function. If there are only one slot in the utterances, it means we need the information about all the products of the specified aisle. To realize this, first, we also need to join the table product and the table aisle. Then we select aisle, product ID, and product name in which the aisle is the specific value we provide. Last, let me test the intent. In order to test the intent, first we need to awake the Alexa and open R scale. Open database system.
Welcome. What query would you like to try? Or you can say, help.
You can see we have awake the Alexa and open R scale. Then we can test this intent. If we want information about all the products in the aisle of butter or butter, we can say, show me all the products in the aisle of butter.
Okay, I have fetched the data.
You can see we have finished it successfully. We have aisle product ID and product name in the aisle of butter. And if we want information about the aisle with the most products, we can say, find the aisle with the most products.
Understood. Getting the data.
You can see we have finished it successfully, and the aisle with the most products is missing aisle, and its aisle ID is 100. The number of products is 1,000, more than 1,000. Then, if we also want information about the top 3 departments with the most products, we can say, find top 3 departments with the most products.
Understood. Getting the data.
You can see we have now the top 3 departments with the most products. It is personal care, snacks, and pantry.
So let me introduce this part of Alexa skill. This is about advanced product intent. Previously, my teammates have introduced the other intent that requires DML language, but users may have little knowledge about DML query. So we designed this part of intent which is friendly to users. They can use normal query language in our daily life. For example, users can say that find top 10 products which has the biggest ratio in department A. Firstly, we should understand what is an intent and what are slots. An intent represents an action that fulfills a user's spoken request. Intents can optionally have arguments called slots. For example, a skill for planning a trip might define an intent named plan my trip that has slots named from city to city and travel date. In this handler, we have 5 slots, which are SEQ represents sequence, and DEP represents department, and NUM represents the number of records, and reorder represents a buyback option, and product represents the product we want to choose. In these slots, they have different slot type. We have defined the domain of these slot values. For example, the product and the DEP slots are products names and the department names in database system. And NUM slots are just Amazon number type. SEQ and reorder slots are little different from others. They have multiple values that map into a same value. For example, if we say buyback, if we say buyback and or repurchase in the input, they will all be considered into reorder string. And if we say biggest or largest, they will all be considered as ASC value in SEQ slot, so that we will find the top n values that are sorted ascendingly. This handler is separated into three main parts, which are sequence function, reorder function, and product function. These 3 functions will put some values in the SQL. You can see here. We will put some values into the SQL attribute, and later in the main part, we will send the request to the server we have, so we can get a response. So when the input contains SEQ slots, then this is gonna be a utterance about like find top 10 products which has the biggest buybacks ratio in department 1. This is equally likely to be the same as the DML query. Here in database system, we select product ID, product name, star as number of cells from other product nature join. Here, because in the other product table, we just have the product ID, and we can not access to the product name, so we have to nature join the product table, and we insert the department values into this language and group by product ID and order it by the number of cells. And this SEQ slot represents the option of ascend or descend. And we also implement the number of values, number of records to get the limit records. Yeah, when the input contains reorder slot, then this is gonna be an utterance about getting reordered information. We can get information like top 5 buyback products. You can see here we have a number of reordered and number of reordered divided by total. This is gonna be a ratio that a ratio of the product that has been reordered again. So we can order it by product name. So we can order it by number of reordered divided by total, that we can get the top 5 reordered product, which is also equal likely to be the most popular product, most top 5 popular. And if we have the product slot value, and then this is gonna be a query that utterance about searching information about products. For example, we can say where is the product, but the product in this sentence should be exactly the product name instead of product. We should say where is bread, something like that. And then we can get the IO ID and IO and product name from product tables, which and the where query would be the same. The product name should be the same in the input. And this is the product advanced intent. Then we will show you how it works. I'm gonna show you the performance of our query system. Firstly, let's activate our skill. You can say database query system.
Welcome. You can say hello or help. Which would you like to try?
Then we can try some utterance. For example, if we are in the store but we want to know the location of soda, the aisles, we can say, where is soda?
Understood. Getting the data.
Yeah, this is the result of this query. Or we can say another product like find the location of Turkey.
No problem. I'll do the job.
Yeah, you can see here we get the Turkey's information. The aisle ID and aisle. We can find the Turkey in lunch meat aisle. And if we want to buy something that has largest buybacks, which means they have good comment, then we can say find top 10 products which has the largest buybacks ratio in alcohol.
Understood. Getting the data.
Yeah, you can see here we find the top 10 products in alcohol that has the reorder ratio very high. You can see here the blank almost has 77% of buybacks. And if we want to buy something for babies and we want to know what is the most popular product in babies, then we can directly say what is the most popular product in babies.
Okay. I have fetched the data.
You can see here, this is the product name, baby food stage 2, blueberry, pear, and purple carrot. This product almost has 310 cells in total. Or if we want to find something popular in all kinds of goods, then we can say find top 10 most popular products.
Understood. Getting the data.
Yeah, this also works. These 10 products are most popular products in the store.